Hey everybody, it's Mr. Fasoni with another video for chapter 6. Today, this video is about the transformations of functions. At the end of the chapter 6.3 and 6.4 assignment, there were two questions about transforming exponential functions. So I'm going to do some examples. These are from the book. I'm actually going to do two from exponentials and two from logarithmic functions. Even though they're different types of functions, remember that transformations of functions work the same on any type of function, whether it's a linear function, an absolute value function, quadratic, etc. So because of that, we can apply these same types of rules over and over again and get the types of results that we want to get. I'm going to open up a Desmos really quick as well. Let's see here. All right. So let's go ahead and do these four problems really quickly. And like I said, I'll graph them to show what's going on as well. So the first one we're going to do is this exponential function. The function f of x is e to the x power, and the things that are happening to it to create a new function that we're going to call g, or g of x, is a horizontal shrink by a factor of 1/2, followed by a translation 5 units up. So let me go ahead and rewrite this really quick. So we're doing this, we're doing this one first. So our original function is f of x equals e to the x power. And the things that are happening are a horizontal shrink, so everything's moving inward horizontally to a factor of 1/2, and it's then followed by a translation. Everything is going to be translated 5 units up. Again, this is my little shorthand. When the arrows are pointing towards each other, it means it's a shrink. If it's horizontal arrows, it's obviously a horizontal shrink. If it's vertical arrows, it'd be a vertical shrink. If they're pointed away from each other with a number in the middle, that means it's a vertical or a horizontal stretch. A single arrow is a translation in whatever direction. And then for a reflection, it's a double arrow, vertical if it's a vertical reflection, one arrow up, one arrow down. And horizontal, it's one arrow to the left, one arrow to the right. It's a connected thing. There's no numbers there. And you'll see that other notation in the ones where there's reflections happening. Okay, so we're starting off with e to the x power. We're shrinking horizontally by a factor of 1/2, and then we are translating up by 5. So remember, everything that's vertical affects, and let me go over here for this. Just a note, everything vertical affects the output or the entire function. That's another way you can think of it. The value of the entire function. So that's going to be anything that affects our y value. And then everything horizontal is what affects the input. And that's our x value. Now just remember though, there's a little bit of a caveat with the horizontals. Everything with the horizontals is actually inverted. So we're taking the inverse. So if we want to add, if we want to move to the right by 5, which is a positive direction for a translation, instead of adding 5, which is what our intuition would tell us, we're actually going to subtract 5 from the x values. And same with the multiplications for stretches and shrinks. Instead of multiplying by the value that we want to use for horizontal, we're going to take the reciprocal and then multiply it. All right, so let's get back to this. F of x equals e to the x. I'm shrinking horizontally to a factor of 1/2 and then moving up by 5 units. So I got this little chart from the lecture the other day. So the things that are happening in this case, I'm going to switch to green. Things that are happening is that we are doing a horizontal stretch or shrink. In this case, it's a shrink. And remember, when it's a shrink, that's the reciprocal. So if I'm shrinking by a factor of 1/2, I'm going to take the reciprocal of 1/2. I'm going to use that to multiply my x value. In this case, my reciprocal of 1/2 would be 2. All right, so I'm going to rewrite this. So step 1, I'm going to rewrite this. I'm going to multiply the input by the reciprocal of 1/2. Reciprocal of 1/2 is 2. So on the function notation side, it would just look like f of 2x. And on the actual statement side, I'd have e to the 2x power. Let's go ahead and demo this up in Desmos. So if I've got a function that looks like e to the x, this is my original function. If I've got another one that matches it exactly, this blue function, so blue and red, they're sitting on top of each other, the exact same function. I'm going to go ahead and put a 2 onto that x value. Oops, there we go. And notice when I put that 2 on, everything gets shrunk horizontally. Everything to the right gets moved back towards the left, back towards center. Everything that's on the left gets moved back towards the right, back towards center. So any value on the red function gets basically cut in half to become the blue function. So that's my shrink, my horizontal shrink. That's the first step. I'll use not green. I already used green, and actually that should have been a green 2 on this, just to keep track of what's going on. So the green stuff is the first step. And then my second step, let me change this handwriting, geez. My second step is I'm going to move everything up by 5. Well, remember, translations are addition and subtraction, and anything vertical is going to work exactly the way we want it to. So a vertical translation, we're just adding some value to the end of the function, to the outside of the function. If I want to move up, it's going to be addition. If I want to move down, it's going to be subtraction. So in this case, I'm moving 5 units up. So I'm going to take my function. At this point, what I'm considering my function to be is the current function, not the original function. So this is my function on both sides of the equation. I'm going to add 5 to that current function. So the blue step is step 2. I got rid of the green on this step because this is now the entire function at the end of step 1. So by adding 5, I'm translating up by 5 units. And I can see that again with my blue graph here. I've already shrunk it. Let's add 5. And sure enough, you can see, I got to move this a little bit, but you can see everything over here has been moved up by 5 from the red graph. So not only has it been shrunk horizontally, it's also been moved up. All right, so that's the first one. Oh, and we're not quite done yet. If we wanted to finish this out, the correct way to write this at the end, this whole thing on the left, I would just rename g of x. My new function, g of x, is e to the 2x plus 5, and that's it. All right, that's number 1. Let's continue to number 2. So number 2 is the function e to the negative x, and I'm translating it 4 units to the right, then 1 unit down, and then I'm following it by a vertical shrink by a factor of 1/3. So there's 3 things happening on this one. So this is the one I'm doing now, step 2, or number 2. Actually, I'll do this one in orange to start. And let me get below it here to write the basics of it. So my original function is f of x equals e to the negative x. And the 3 things I'm doing, I'm translating 4 to the right, then 1 unit down, and vertically shrinking it to a factor of 1/3. So that's my notation for a vertical shrink. All right, so let's go ahead and do this. So again, translations are easy. These are just addition and subtraction. Remember, the horizontal translations are going to be all backwards. So if I'm moving 4 to the right, even though that's a positive direction, I'm actually going to be subtracting 4 from my x value. So my first step, my first step here is to rewrite it like this. I'm going to be subtracting 4 from x. So f of x minus 4 is equal to e to the negative x. Well, it's going to be minus 4 as well. So that's my first step. Let's go ahead and graph this out to see what's happening. I'm going to clear these real quick. So the first one is e to the negative x. And the second one is g to x equals e to the negative x as well. Okay, so they're the same thing to start. And what I'm going to do is I'm going to translate. Oh, let me put this in parentheses. It's not behaving. I'm going to add, wait. Oh, I'm sorry. I'm going to the right by 4, so I'm going to be subtracting 4 from x. And as you can see, everything got moved over by 4. You've got the red graph here, that's the original graph, and everything got shifted over by 4 units. You can find a point like around -2, for instance, on my x value. All those x values got moved over 1, 2, 3, 4, and there's -6 now. All right. And actually, this one's the easiest to see. At 0, 1, I get moved over by 4. My new graph, the corresponding point is -4, 1. All right, so that's step 1. Let's continue along. Step 2 is a translation 4 units down. But remember, up and down stuff, vertical stuff, affects the entire function. So for this second step, I'm considering this is now my entire function. I'm not the original function anymore. So what's going to happen here is I've got f of x minus 4. That's my function after step 1. And then step 2 is going to be -1 to shift it down by 1 vertically. E to the negative x minus 4. You can put this in parentheses if you want to just keep track of what's going on there. And then -1. So that's a vertical translation by 1 unit. And again, I can show that on this blue graph. If I subtract 1, everything is now 1 lower than the original graph. All right, that's 2 steps down. Last step is a vertical shrink by a factor of 3. I'll use this gray color. So vertical shrink by a factor of 3, that means it's a vertical, so it's affecting the entire function. And a shrink of 1/3 means I'm multiplying by 1/3 on the entire function. Well, again, on this step, this is now my entire function. So I'm going to take my entire function, f of x minus 4 minus 1 equals e to the negative x minus 4 minus 1. And I'm going to multiply that whole thing by 1/3. This is affecting the whole function. So not just this first term, but also the second term. So I'm going to put that in parentheses. Actually, I might have to fiddle with this a little bit because I put it pretty close. But this is all in parentheses. I'm multiplying the whole thing by 1/3. So I can either leave it like this, or I can distribute through. This 1/3, it's on the outside of the parentheses, so due to the distributive property, it's going to be distributed to both terms. So what I end up getting at the end is 1/3 f of x minus 4 minus 1/3, because of the distributive property, is equal to 1/3 e to the negative x minus 4 minus 1/3, again, due to the distributive property. Now we're almost done here. This left side of the equation, at the very end, I'm going to rename that. What do I do with the, okay. Very end, I'm going to rename it. I'm going to change this name to g. This is my new function. G of x is equal to 1/3 e to the negative x minus 4 power minus 1/3. So again, if I want to graph this, I'm going to put this whole thing in parentheses. And then I'm going to put a 1/3 out front. Uh-oh, what did it do? I don't think it liked these parentheses. Let me change this. There we go. Okay, so now it's shrunk everything vertically down by 1/3. And I can check that very easily. I've got the point 0, 1. What happened on this 0, 1? The first thing I did was shift it to the right or to the left by no. Not to the. Did I goof up here? Let me check. Oops. Might have goofed up. Let me check. I'm going to the right by 4. I messed up my directions, didn't I? I was meant to go back to the right by 4, but I've got a negative 4. What did I do wrong here? Oh, I made a big mistake here, guys. I apologize for this. So this is a tricky question here. If I want to move to the left or to the right by 4, which is what my problem was asking me to do, typically, if x was just a normal x, if I added 4 to it, it would go to the left by 4. If I subtracted 4 from it, it would go to the right. Let me show this. So if I have e to the x, and if I add four to it, I would go to the left by 4. 1, 2, 3, 4. There's my blue point. If I subtract 4 from it, it would move me to the right by 4. But because my x was negative to start, I didn't catch this, I apologize. I forgot to mention, if I have a negative x to start, then if I want to move to the right by 4, I actually have to go back to using a positive 4. So that was a little mistake there. It's easily fixed though. So on the first step, my purple step, this became a plus 4. And then on these subsequent steps, these negative 4s become plus 4s. Not a huge deal. It just plays into this whole counterintuitiveness of how the input values are handled in transformations of functions. Because I had a negative x to start, you can think of this negative x plus 4. Another way to think about it is something like this. The negative sign on the outside, which changes this sign on the 4 from positive to negative. So again, I apologize. That gets very counterintuitive when we think about these transformations of functions. So what results here, let me step through this again. First step, I would do a plus 4 on my x value. Because I've got this negative sign in here, I have to flip it again. So now it's back to being the way we would normally think it would be intuitively. So I'm going over by 4, 1, 2, 3, 4. And then I'm shifting down by 1. Do that, minus 1. So now 0, 1 gets shifted over 1, 2, 3, 4, and then down 1. And I have a point somewhere there, 4, 0. And then finally, the last thing I'm doing is I'm multiplying by 1/3. And this multiply by 1/3 causes everything to shrink to 1/3 the height. Now it's kind of hard to see here, but basically, uh-oh, everything's getting goofed up now. 1/3 the height shrinks it to, shrinks it vertically. So you can see this blue line, which was below the x-axis, got kind of moved up closer to the x-axis when I multiplied by 1/3. So that ends up being my final format on this. And I wrote it with parentheses, but I can create a third function just to show it without the parentheses that it would work. And notice that the green and the blue are exactly the same. But when I did this without the parentheses, I had to distribute that 1/3 into the -1 to make it -1/3. Right, that one was a bit of a doozy. I apologize for the confusion on that first step. I know that goofed things up a little bit. So our final answer would be g of x equals 1/3 e to the -x plus 4 minus 3. All right, so let's go ahead and jump over to the logarithmic ones. I'm taking up a lot of room on this. Zoom in. Okay, I'll do these ones over to the right since I've got some blank space. So this next one I'm going to do, f of x equals log base 1/2. So in other words, what power of 1/2 will give me x? That's what this function is telling me. And the two operations, or three operations I'm going to do. The first one is a translation 2 units left. And then, or not 2 units left, 3 units left. Second one is 2 units up. And the third one is going to be a reflection in the y-axis. So remember that the y-axis is acting as the mirror. So everything on the left gets reflected to the right. Everything on the right gets reflected to the left. All right, so let's step through these. The first one is a translation, so it's just an addition and subtraction on my input value. Since I'm moving to the left by 3, it's going to be a +3 on my x value. So let's write this very quickly. It's going to be f of x plus 3. That's going to be equal to log base 1/2 of, put this in parentheses, x plus 3. And again, I can check this in Desmos pretty quickly. I'll go ahead and delete the first one. Log base 1/2. Let's see if I can actually do this. Oh, geez. Having some trouble here. Log base, let's see here. No. Log base 1/2 of x. So let me put this into the subscript. All right, log base 1/2 of x, and then the other one is log base, let's go. (1/2) of x. So I've got both of these functions to start off. Blue and red are the exact same thing. The very first thing I'm doing on this bottom one is I'm taking 3, or I'm taking x and I'm adding 3 to it to have it move to the left by 3. So I'm going to add 3. And sure enough, now my blue graph is the same as the red graph, it's just 3 to the left. You can see that there's a space of 3. Here's -3, here's 0, and they both approach those two numbers as we move to the left as far as the x coordinates go. All right, so that's our first transformation. Our next one, we're moving up by 2. Remember, up by 2 is just going to be adding 2 to the entire function. So on step 2, my entire function is now this after step 1 is done. So it's going to be f of x plus 3 on both sides of the equation. I've added that 3 to the x. And then what I'm going to be doing is adding 2 to the entire function. And again, I got a little bit too close there. So now I've got f of x plus 3 plus 2 is equal to log base 1/2 of x plus 3 plus 2. Again, I can go in here and I can add 2, not equals 2, let's try that again. Add 2 to the function, and everything is going to get moved up by 2. Again, it's kind of hard to see, but if I go way out here, you can see that this space becomes about 2. Right here, I'm about at 3.5. I go down, I'm about at negative 5.5. And it gets closer and closer to exactly 2 as we move to the right. So everything gets moved up by 2. And again, I can find another point of interest, maybe one that's a little bit easier to see, like this point right here. Ooh. 0.5 comma 1, that's my original point. That means I'm going to have a corresponding point 3 to the left and down 2. So if I go 1, not down 2, up 2. If I go 1, 2, 3 to the left, and then up 1 and up 2, there's my corresponding point, negative 2.5 comma 3. This point here corresponds with 0.5 comma 1 because it's 3 to the left and 2 up from that first point on the red graph. All right, so that's my second translation. Last thing I'm doing is I'm doing a reflection horizontally over the y-axis. Remember, a horizontal translation means I'm multiplying by -1 on the x value. So I can go ahead and find my x value. I'm going to multiply that x value by -1. So that's the only thing that's going to change on this function at this point. So I'm multiplying the x by a negative. So finally, we go back to Desmos. Last thing I'm doing is multiplying it by a negative, and that causes a horizontal reflection. Every value to the right of the y-axis gets reflected over to the left and vice versa. And a point that you can again see very easily is 1 comma 0. If I put that negative in front of the x, now my value is -1 comma 0. You can just see that reflection. And that's it. That's our last stage. We're done at this point with this problem. And the last thing we're going to do is just rewrite it as a new function we're going to call g. So g of x is equal to log base 1/2 of -x plus 3 plus 2. All right, so that's question 3. Let's do the last one. Last one says natural log of x, and then it's got 3 things happening. We're translating 3 units to the right, and then 1 unit up, and then horizontally stretching by a factor of 8. All right, so let's do this. So again, we're going to start with our function, natural log of x. First thing I'm doing is adding 3 to the right, which means I'm just doing a -3 on my x value. Oh, and this should have been f of x. So it's going to be f of x minus 3 is equal to the natural log of x minus 3. Step 1, done. So let's go back to Desmos and see what it looks like really quick. Natural log of x, whoa, natural log of x. And then on the bottom, I'll also have the natural log of x. Those are my 2 graphs. They're on top of each other, exact same thing. I'm going to modify my x. What was I doing? I was subtracting 3 because I'm going to the right. And sure enough, now any point on my x or on my red function, 1, 0 gets moved over 3, 1, 2, 3, 2, 4, 0. So that's my first point, or my first change. Second change is I'm moving the entire function up by 1. So I'm adding 1 to the entire function. Remember, with the entire function, I'm taking whatever the current state of the function is, not the original function. So I have f of x minus 3 is equal to the natural log, and actually I should give myself some space, is equal to the natural log of x minus 3. And I'm going to add 1 to both sides of the equation. And it's affecting the entire function, so it's outside of where the x is. So again, I can go to Desmos. If I just add 1 to this, you'll see that the graph moves up by 1. It's kind of hard to see here, but if you zoom way out, go way out into the right, then you can quickly see I'm at 260, 5.5, or 6.5. There's a difference of 1. And again, we can find a single specific point of interest that's maybe a little bit easier to see on the red graph. The point that we're going to use is 0, 1, or I'm sorry, 1, 0. 1, 0 got moved over by 1, 2, 3, and then up by 1 to the point 4, 1. All right, one more thing to do. Vertical stretch by a factor of 8. Okay, so that means I'm multiplying the x by 8. All right, so I got to find my x value. Well, there's my x value. I'm just going to multiply that by 8. So I get f of f of 8x minus 3 plus 1 is equal to the natural log of 8x minus 3 plus 1. Now, if I multiply this by 8, oops, did I say horizontal? I'm losing my mind. Apologize, guys. That's what happens when you record while you're tired. All right, multiply x, not by 8, it's horizontal. I have to do the reciprocal of 8 by 1/8. Apologies. That's going to cause a horizontal stretch by a factor of 8. So let me go ahead and fix this. 8 would shrink it. Where's my? If I did an 8, it would shrink everything by a factor of 8. I want to do it by 1/8. That's going to stretch everything out by a factor of 8. So if I want to find my value again, I'm going to find a value that I can see on my red graph. 1, 0 is a great point because it's nice whole numbers. There's 3 things happening. I'm getting shifted to the right by 3. 1, 2, 3. Up by 1 to 4, 1. And then that value, that 4, is being multiplied by a factor of 8. So I should be able to go out all the way to 32, 1. And there it is, 32, 1. So that's the corresponding point to 0, 1 on my original red graph. And remember, every point on the blue graph has another point on the red graph that it corresponds to, that's been transformed from. All right, so that's the last example. Oh, I guess we need to finish it up. Finishing touches would just be to rewrite this left side as g of x, instead of equal to the natural log of 1/8 x minus 3 plus 1. And there we go. All right, so I hope this is informative. I hope this helps on the homework. Remember, it is due on Monday night at 11:59 p.m. Have a great rest of your 3-day weekend, and we'll see you on Tuesday or Wednesday.